Today we will learn about multi-class segmentation. What does it mean? This is our image. It has two players, a ball, a grass, and a crowd. So we will learn how to build a model that segments all the objects inside our original image. As for Yolo V8 installations part, it was covered in my previous video. Here is the link. Okay, so let's start. So this is the instruction file. So basically this step number one is preparing the data. This is the link for the dataset for the Kaggle website. Of course, I will leave a link in my video description to this file and for the rest of the code that we will type it later. So first of all, let's go to this website to see the dataset. So this is the dataset. As you can see, it's a football semantic segmentation. We can see here that there are images, and there is also one big giant JSON file that has all the annotations of those images. So let's click here and download all the dataset. As you can see, this is the folder after we are extracting the zip file. There are images, and there is a big JSON file. It will take about a minute to open it, but basically it contains all the annotations of the segmentation, all the points, all the dots on the images. If we open the images folder, you can see that they are let's say sorted by name. As you can see, this is the first image, and this is a football image. If we are continue to the second image named frame 1 fuse, you can see the masks, a player, a gate. You can see there is a difference between one team and another team. This is another masks image. So if you can see, frame number 1 has 3 files. One is the original image and 2 more images that are not relevant to our training, because all the information already stored in the JSON file. So this is image number 2, as you can see, and this is image number 3, and this is image number 4, image number 5, and basically what we need is to convert all the annotations that's stored here in this JSON file. We have to convert it to a Yolo format, since we are going to use Yolo V8 to do the training process, to do the segmentation process. So in order to do that, we will use any software or any website that can convert from a JSON format to a Yolo format. I prefer to use RoboFlow. This is a free website. You can create your own free user. So let's create a new project. Let's name it football seg for segmentation. We have to choose an annotation, dogs, like dogs, car. We can write football, not really important. And this is really important. What is our type of project? Object detection, classification, or instant segmentation? We are using instant segmentation, and let's create a public project. So this is the workspace. As you can see on the left side, there is a menu. We will cover this in a moment. And here we can see the main ability, the main functionality to upload our files. But in order to do that, let's create a new folder. Let's call it for RoboFlow, and let's copy the JSON file to this folder, and let's also copy the images, but not all the images. As you can see, these are JPG images, and those 2 masks images are PNG files. So let's sort it by type. So now we can grab all the JPG files which are the original images. As you can see, we have about 100, and let's copy it into our for RoboFlow folder. Okay, now it's done. So now let's go back to our RoboFlow environment and let's choose a folder. So we will choose here for RoboFlow, the one that we created, and let's click on the upload button, and yes. So basically the process now is that the RoboFlow environment upload the JSON file. The JSON file basically contains all the classes. The class is like a football, like a player, like a goalkeeper, like a referee. We'll see all the classes that are already annotated, and all the images as well. So our project in the RoboFlow will contain all the data, and then we continue to the second step, which is converting or extracting all the information back to our local machine to a YOLO format. So as for now, we have to wait a few more seconds until the upload will finish. As you can see, this is the upload for all the images, and I believe it's done. So let's save. It's very important to save. And when we click save, we get a recommendation that the environment, that the RoboFlow will split the data 70% for train images, 20% for validation images, and 10% for test images. It's a very good recommendation, and we will use it and take it, since when we start the training, we would like to train all the images on the 70%, then check it on the validation data during the training, and the test would be out of the scope, so we can test 10%. It's about 10 images, since we have 100 images, so 10% will be left, and we will check them after the training. So we will click now continue, and we are still uploading. As you can see, there are about 4 or 5 seconds, so let's wait a few more seconds for this process. So let's go to see the information. So let's click here, classes. As you can see, now the data set has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 classes. So we are expecting to find in the images the class of advertisement, the audience, the ball, the goalkeeper of team A, and the goalkeeper of team B. So as you can see, they did a great job doing all these annotations. So let's watch the dataset, and let's open image number 1. Okay, on the left side here, you can see the classes. This is player of team A, this is player of team B, this is the grass, the ground, and this is the audience. Let's see another image number 2. Once again, this is the ball, this is the goalkeeper, this is the grass, player of team A, and 2 players of team B. Another image, ground, team A, team B, and this is the ball. Great. So as you can see, all the train data already has all the annotations inside it. So this is the dataset along with the JSON file. It's all merged together. So now basically what we need in order to do the training, we need that all the data will be in YOLO format. So in order to To do that, on the left side, we go to the Generate menu. So in order to create a version of our dataset, as you can see, there is more information. This is the source images, about 100 images divided to 10 classes. We also split the data already to a train, validation, and test. And there is another recommendation of doing auto orientation and resize of all the images to 640 by 640. This will reduce the time of training, since Yolo V8 was already pre-trained on those dimensions. So basically we can click the continue button and continue to the next step. As you can see, we have here a new version. Okay, now it's done. The last phase is export. As you can see, we have an export button here. So let's click this export. And as you can see, there are several formats for export. We will use the Yolo V8, and we will use download zip to our computer. And let's click continue. As you can see here, it's finished the downloads. Let's open the zip file, and now as you can see, we have all the information stored in this zip file. We have train, and inside the train we have images, and also we have labels, and these labels are in Yolo format. For example, this is class number 8, and we have 4 values: X, Y, width, and height. This is the Yolo format. And we have the same for the validation and for the test, and we also have the YAML file. We will explain about it later on. Okay, so I extracted the zip file. As you can see, the name, in my case, after download, is football seg1i Yolo V8. Probably in your case it will be a similar name. And inside this folder we have the training images and all the labels, and as I mentioned earlier, we have it for the test and the validation. And a very important file is the data YAML. This is a very important file. It contains all the relevant configuration and pointing to the images, and also contain information about the classes. So we'll explain it later on. So the next phase is the training. So we would use the Yolo V8 model, do some customization, and run a training on our custom dataset. So let's create a new and fresh Python file. Let's name it step number 2, train football. So we will start with import the Yolo object. Let's create a main function, and let's create an instance of our Yolo object. And we are also sending an argument, which is the Yolo V8 large segmentation. Project argument is basically the path where all the results of the training would be stored. Next experiment is the name of a subfolder under the project folder. It will be enumerated for each training. Batch size 16, mean 16 images per batch. And now let's start the training. So the train function we will send it several arguments. The first one is the name of the config YAML file. Don't forget to change the direction of the slashes. Then inside the config file we will change the full path for the train images and validation images and the test images as well. As you can see, I'm changing the full path for train, val, and test. Okay, let's copy paste for the rest of the folder. Great. Next, how many epochs? It really depends upon the time you would like to wait and the amount of your data sets. Let's run it on 200 in our case. Then the project and the name are the project and the experiment name. Also, we are sending the batch size, which is 16. Next, device 0 means the first GPU card. Image size would be 640. This is the conventional value for Yolo V8. Patience 30 means that it will wait 30 epochs. If there was no improvement, it will stop training. 30 out of the 200 epochs. So let's add the underscore name in order to run the main function, and let's start running. Now, as you can see, it loaded 69 train images and now 20 validation images, and it started the first epoch. Please follow the seg loss value in the starting point is 3.6, and if you follow the training, you can see that the value goes down. It's being reduced. It's a good direction for us, and we will not wait 200 epochs. Let's pause here the recording, and let's jump directly to the ending of the train. As you can see, it's about 196 epochs, and the segmentation loss now is about 0.6. So it's a very good value, a low value. So in this folder, we will find all the results of the training. And also, if you follow the rest of the values for each of the classes, you can see that the segmentation loss is very low. The best.pt is our best weights model, and if we will open the results file, and we will follow the segmentation loss on the training process, you can see that it's going down. So the training is very good. Let's also open the val batch, the first batch. You can see also some classes that are already segmented. I think we have a good results. So let's test it now on a new and fresh image. I took one image from our test folder. So let's use it now. Let's create a new Python file. Let's call it step number 3. And we will start with importing once again the Yolo object. And let's also import NumPy, OpenCV, and the random library. We will need it for choosing a random color for each class. So this path is for the best PT, means this is the best weights of our training. We will use this file in order to run the test. Now this is our test image. Let's put the path for this image as well. Don't forget to change direction of the slashes. Next, let's load our test image using OpenCV. And also let's grab the dimensions of this image. Next, let's print the shape of the image. We would like to double check that it was loaded correctly. As you can see, this is the dimensions of our image. Great, let's continue. Now let's create a new instance of our model. We will send as an argument our best model weights, and let's run the inference. We will use the model function with our test image and get the results. The results contain a lot of information, and we will start with grabbing the names of our categories. So let's run it. As you can see, these are all the values of our classes. We will use it in order to grab the name of the class. Next, we have 10 classes. Let's create a list that will contain a random color for each class. And let's run through all our 10 classes and choose a random color. Since we have in each image 3 channels, blue, green and red, the random will choose a number for each of these channels, and we will merge it together to create a one random color, and then we will add it to our random list. So basically each of the classes will have one random color. This, for example, the 10 random colors. So class number 0 will have a different colors from class number 1, for example. So now the next phase will create an empty mask. It will be in the same dimensions of our image. So basically we are creating an empty image, a black image, in the same dimensions of our test image. Now let's grab the predicted class from the results variable, and as for a start, let's print the predicted results. So we have, as predicted, classes number 9, 8, 6, 9 and 1. Okay, but we still don't know what is the meaning of all these classes numbers. So let's iterate through all those masks, and let's grab each of those masks, and for each of those masks let's print the number of the mask. So what is the ID of this mask? Let's call it the class ID, and let's also get the name of each of those masks, and let's print it one next to each other. So we are expecting to see object number 0 is, for example, indicates team A, and object number 2 may be the goalkeeper, and object number 3 can be, for example, the ball. So each of those numbers represent one of the classes, and let's print it, the class ID and the class text. As you can see, we have 5 different predicted classes, and we also have the names of those class ID. And the next phase will be extracting the mask area, and then we will color this mask area with one of the 10 random colors. As you can see now, we are grabbing the colors for a specific class ID, and then we apply this color mask along with the final mask, and this will basically create a final mask that contains several masks inside it, and each mask will be in a different color. It's like a panoptic segmentation. Okay, the next lines generating our colored mask. Since we are running through a for loop, each time we are generating a specific mask, and this specific mask with a specific color will be merged later to our final mask. So in order to do this merge process, we will use the maximum function, and since the basic value in the final mask are zeros, they are black values, if we use the maximum function, all the black dots will be replaced with the colored mask. Let's also choose a file name for each of those masks, and we will save it in our local folder with the name output with the number and png as a suffix. And at last we will also save our final mask as a final mask.png. So we are expecting to see an image file for each mask and also a final file for all the masks together. So now let's display our original image, and let's also display our final mask, and let's also put them one next to each other and display it using pyplot. So let's create a subplot for that, and basically we are creating one image that has two areas. In area axis 0, let's put our original image, and in area number 1, let's put our final mask, and let's run it. So we're expecting to see two images. On the left side is the original image, and on the right side is the predicted mask. As you can see, a very good result. Thank you very much. I hope you enjoyed this tutorial. Bye bye.